In every generation, there's a moment where everything changes. A breakthrough that ushers in a new way of doing things and ensures the world will never be the same again. This is one of those moments. Introducing GE Additive, a new business that represents GE's passion for the industry and its tremendous potential. Its capacity to make complex parts that were once impossible to produce, to speed up the manufacturing process, and open up a whole new world of design possibilities. At GE Additive, we're leveraging digital industrial capabilities and new technologies to accelerate innovations across industries. From aerospace, power, and automotive, to medical, architectural, and consumer applications. And as a leading user of additive parts, we're committed to delivering world-class machines, materials, and services for customers around the globe. And once again, expanding the boundaries of what's possible.
Ladies and gentlemen, please welcome Vice President and General Manager of Additive Integration at GE Additive, Mohammed Etashami.
Good afternoon. This morning you heard from Jeff and Beth about digital twin, about digital thread, and about additive. I want to take 1 minute to define what additive is and how it is created. Additive is when you create a 3D model in a computer-aided design and then put that into a machine and a physical entity comes out. That is called additive. It is opposed to the traditional manufacturing where you take a chunk of metal and you carve it out. In GE, we've done significant research and development, and in all our industrial businesses, we've been working on creating parts, components, and systems for over a decade now. If you look at our power, aviation, transportation, oil and gas, and healthcare, these are parts that they are a lot easier to manufacture using additive than traditional manufacturing because the design sophistication has gotten better to produce better efficiencies. Additive is where digital becomes a reality. When you take digital thread and you think about digital and physical meeting each other, that's where additive becomes very, very important. Let me take a minute and walk you through how in GE Aviation we came across creating additive manufacturing and what benefits we have gotten from it. It was in 2011, 2012 where we wanted to push the efficiency of the jet engine beyond anything we've done ever again. And one of those components is a fuel nozzle. The job of a fuel nozzle is to deliver fuel in the combustion chamber, so it has a lot of sophisticated parts in it. We realized if we use traditional manufacturing, we will not be able to get the efficiency we wanted. Therefore, we came across a company called Morris Technologies. Later on, we acquired that company and became part of our GE Aviation. This part that you see on the screen, it's the fuel nozzle. And each of our LEAP engines have 18 or 19 of these parts in them. Today, as I speak to you, the A320neo is flying all over the world with these parts in it, and it's been certified for over a year now. The same thing with Boeing 737 MAX, and the same thing with C919, the Chinese manufactured plane. On the left-hand side, you see the X-ray of the fuel tip. It is very sophisticated. They are passages very, very small, as thick as 2 times of a human hair. Traditionally, we were not able to make this. It would have taken 20 to 25 welds, braces, joints to create a part that was subpar to this part. When we started playing with this technology, we realized we can take 20 parts to one. We can reduce the weight of this system by 25%. We collapsed the cycle of development by 50%, and we increased the durability of this product by 5x. As an engineer, we always trade between weight, strength, durability, and efficiency. When I saw this for the first time about 8, 9 years ago, I said, oh my God, for 30 years I've been frustrated trying to do those trades. This technology makes it much, much easier. So once we did that, we realized that we can go beyond just the fuel nozzles. We put a skunk work group together, 8, 10 engineers, and we gave them an old engine, a 30-year-old engine called CT7. It's a helicopter engine. We said, go try to see how many of these parts and systems can you print. So the team took a little bit and came back. They said, we can print about 35, 40% of this engine as is today. They took 900 parts and made them to 16 parts. They took 35% of the weight of those 900 parts out. And they did it in 18 months and 2 days. They took the cost down by 30 to 40%. What I want to share with you, this is the first time we're actually showing it in public. This is a combustor chamber for that CT7. It has thousands of holes in it. Traditionally, it takes 30, 40, 50 parts to make this, and it takes about a year to design it, make it, test it, and then say, yep, it's good for emission, it's good for fuel efficiency. This thing was done in less than 6 months, the whole total cycle. It weighs 30% less. And traditionally, it would take 5 to 6 engineers to do it. 1 engineer did it. Imagine how much you can simplify the supply chain. I also want to show you what the creation of the CT7, what it led us to. We have a new product. It's called Advanced Turboprop Engine. It is being designed and manufactured in Europe with our European colleagues in Italy, in Czech Republic, in Poland, and in Germany. This engine is brand new. We took 855 parts down to 12 systems. Actually, I have some of the parts here I want to show you. This is a part, it's a bearing support and sump. Traditionally, this sump would be 3 times thicker. With this technology, we can print these patterns on it that gives us the stiffness we want. It would be 80 parts separated, and you have to assemble it together. It's all gone. It's 1 part now. This is another part for the same engine, okay? This part would have weighed twice as it weighs today. We printed this thing in less than 2 weeks. And the patterns are, again, evidence here that you can put the stiffness the way you want it. Remember how I said it's a 3D model that you can design it the way you want the strength to help you? This is how additive does it. Not only we saw many advantages in GE Aviation and other GE businesses, we also looked outside of GE to see what else is going on. What you see on the screen here, it's a hip replacement joint. It's a ball and a socket. This product went to the market in early 2016. It is called acetabular cup. It is created to resemble the human bone structure, so the human tissue can grow into the porous area. when we look into the medical implementation and beyond, the opportunities are enormous. I want to show you a couple of more parts. What I have in my hand is an oil pump. It is for a motorcycle. Traditionally, this thing will be 3 times heavier and much bigger. The efficiency of this is twice better than existing product. And I got a few other parts in here that this, by the way, this is the cup that I showed you on previous page, okay? So on the screen, you see the video showing how the additive is printing layer by layer. Each of these layers are about 50 micron to 100 micron thick. You are creating the physical part, but you're also creating a digital twin. And all the data that you're capturing about the quality of what kind of process you are using to create will remain with the part. And as it goes through the process and it goes to the field, you can track it to see how it behaves. This is where we say additive is where digital becomes a reality. Traditional manufacturing, when design gets sophisticated, it gets more expensive, the cycle gets longer, and the supply chain gets more complex. Not with additive. Additive actually simplifies all of the above. So we see growth across all areas. In terms of materials, GE has a strong culture of material science and material creation. For the machines, these machines that we will create will have predicts built in them. As you may have read, we are in process of acquiring 2 European great companies that they're going through the legal process now. And then engineering and engineering services will be something that we will offer to our customers to make sure they understand the machine and they can use them optimally, and we will provide the support for them. So I mentioned earlier about all of the GE businesses that they are using the additive. But this is a bigger global ecosystem from our GRC, Global Research Center, that has hundreds and hundreds of engineers around the world, to places that we actually have both production and development around the globe as we go with our engineers. And then I mentioned earlier how we can enable through additive and create by predicts. If you can imagine that 3D model going, it's a bunch of ones and zeros that goes through that machine, and finally a physical part comes out. This is all the digital thread, and all that information becomes available. And then finally, our goal is to provide 10,000 machines over the next 10 years to our customers outside of GE, in addition to satisfying the GE needs for another 1,000 or more machines. Thank you very much. I appreciate you listening.